Hi, welcome back. This is part three. In part three, we discuss uh, the Greater Antilles, or I should say, we begin our discussion of the Greater Antilles, and we start with the island of Cuba. With a surface area of about 80,000 square miles, the Greater Antilles account for about 90% of the landmass that you find in the West Indies. In parts three, four, five, and six of this overall presentation, uh, we talk about the geology of the main islands of the Greater Antilles. Uh, these, of course, would be Cuba, Hispaniola, Puerto Rico, and Jamaica. Uh, Part three, which is what we're in right now, we start with the island of Cuba. Now, before I start this discussion, I'd like to say a few words about some of the key references on this general topic of the Greater Antilles. Well, listed on this slide are the key references that I think are applicable to the Greater Antilles. Again, many authors have published, but these are the ones that I found extremely helpful to me in my research. They range all the way from 2016 to 1945. But listen, some of the older references are really, really good because these people did a lot of good work and they have very good descriptions of what they saw and the geology of this area. Again, all of these are listed under part 13. Okay, let's talk now about the physiography and the geology of Cuba. Now, I got to tell you that when I was growing up on the island, I had no idea that I was ever going to become a geologist. I did not discover geology until I was a junior in college. Uh, in fact, I wanted to be a professional baseball player, but I was never good enough. Uh, Interestingly enough, my paternal grandmother was at least part owner of some of the copper mines in the central portion of the island. So who knows? Who knows? Maybe I would have drifted in that direction anyway, but I don't know. Now, Cuba has an area of over 42,000 square miles. It has a length of 777 miles and a width of 119 miles. So it is a big island. Uh, Palmer in 1945 has described the main physiographic provinces of Cuba. Those are highlighted here on the diagram that I have presented here for you. You should know that the three main mountain belts in Cuba include the Organos Mountains on the west, the Trinidad Mountains in the central portion of the island, and the Sierra Maestra Mountains in the east. The highest elevation occurs in the area of the Sierra Maestra, and it is called Pico Turquino, with an elevation above sea level of nearly 6,500 feet. There are some iconic physiographic landmarks in Cuba. In the western area, in the area of the Organos Mountains. These are the famous Cuban mogotes, or limestone mounds in a karstic topographic depression, again in the area of the Organos Mountains. As a youngster, I remember climbing one of these mogotes. This is a beautiful view of the Vinales Valley of Cuba. The photograph is by Tony Noshman, SK. The Vinales Valley occurs in the westernmost province of Cuba, in the area of the Organos Mountains. And here's another beautiful photograph by Tony Noshman, SK. It's basically one of the famous Cuban mogotes, or limestone mounds, that are found in this area. The western and central regions of Cuba are a deformed orogenic belt that formed from the collision of an island arc in the Cretaceous with the Florida Bahamas platform. Uh, uh, Due to this collision, an ophiolite belt on the island became abducted, creating a northward leaning fold and thrust belt. Uh, Believe it or not, central Cuba has a zone of Proterozoic metamorphic rocks. Proterozoic. Who would have guessed that? Well, Jurassic and Cretaceous outcrops are very plentiful throughout the island. Well, let's talk about the orogenic episodes that took place in Cuba. Uh, the first and oldest tectonic episode, or orogeny, if you will, is of Jurassic age and consists of folded metamorphic rock. A second and subsequent pre-Cretaceous orogenic episode was responsible for the folding of some of the carbonates that are found on the island. A third and very intense orogeny, uh, characterized by folding and low-angle thrust faulting, occurred in the Eocene. A fourth orogenic episode took place in the Oligocene. But we're not finished. A fifth orogeny occurred in the Miocene epoch. Although it was not as intense in its degree of deformation as some of the ones before, uh, it actually raised the island into a single landmass rather than the previous system of scattered islands. Following this, high-angle block faulting occurred. In eastern Cuba, this deformation is represented by a north-tilted fault block, the one that we call the Sierra Maestra. Now, as a point of interest, I have to tell you that Cuba's Cretaceous to Tertiary marine fauna consists of foraminifera, radiolarians, corals, echinoids, and mollusks. But here's the catch. The fauna is not considered characteristic of North America, but that which is closer to that is found in Egypt and Iran. How about that? Now, there are plenty of igneous rocks in Cuba. Uh, the intrusive rocks that we find on the island are both felsic and mafic. Uh, Felsic plutons are found in the southern part of Cuba, along the Trinidad Mountains, and in the Sierra Maestra. So we're talking the central and eastern portions of the island. Mafic plutons are more predominant, if you will, along the northern part of the island. Now, the extrusive rocks include about 6,000 feet of lava flows, volcanic tuff, and volcanic breccia. Basalt is the main component of the Sierra Maestra Mountains, with thicknesses somewhere between 13,000 and 18,000 feet. Basalt is found in the eastern side of the island, and pumice is found in central Cuba. Okay, now let's have a summary of the important lithologies that we find in Cuba. We'll start with the so-called basement. The oldest rocks on the island are, as I told you before, metamorphic and of Proterozoic age. Other so-called basement rocks are Jurassic to Cretaceous units. An ultramafic complex of serpentinized peridotite intrudes the older metamorphic strata, and in turn the ultramafics are unconformably overlain by Cretaceous volcanic tuff. As far as Jurassic strata, that includes an older sequence of about 35,000 feet of folded shales, slate, phyllite, and schist, and a younger series of unmetamorphosed dark color limestone, shale, and chert with thicknesses that range between 1,000 and 5,000 feet. Well, what about the Cretaceous lithologies? Well, I should point out to you that only Upper Cretaceous rocks are found in Cuba. The highly folded Cretaceous rocks consist of a clastic facies and a carbonate facies. The clastic facies is composed of coarse-grained calcareous sandstone and marl, capped by sandstone shale, and listen to this, a conglomerate with lithologic components that are not indigenous to the island. The carbonate facies is comprised of limestone along the northern side of the central portion of the island. Rocks of the Eocene epoch consist of shale and quartz sandstone in the western portion of the island. Eocene carbonate and clastic rocks are found throughout the island. You should know that the sea was deepening throughout the Eocene, so the waters were getting deeper during the Eocene epoch. Conglomerate and sandstone are overlain by other coarse-grained clastic sediments, as well as fine-grained shale and deep-water chalk. Oligocene rocks are mainly shale, limestone, and coral reef units. In the Miocene epoch, most of the island of Cuba was submerged. Carbonate deposition became widespread, unconformably overlying the older lithostratigraphic units. Miocene rocks are also found in a few of the island's estuaries. Pleistocene rocks are represented by terraces found in several parts of the island. Well, this includes part 3, so let's go to part 4.